Hello and welcome to the Cloud Multiplier. This is episode 5. I am your host, Gurney Buchanan. Unfortunately, Joydeep wasn't able to join us today. He is feeling a little under the weather, and I encouraged him to take some time to get better. So hope Joydeep will be back next time in 2 weeks. But I have the pleasure to be joined by Mike and Mikela from the Open Cluster Management community. So today we're going to be talking all things open cluster management. I'm really excited to have them here. It's a really exciting CNCF Sandbox project that I've had the opportunity to work with and work alongside these folks for a good little while. So welcome to the show, folks. We'll do a little round table. Mike, you want to kick us off, introduce yourself a little bit?
Yep, I'm Mike Yang. I'm a developer from Red Hat. I work on the Red Hat Advanced Cluster Management project. I'm also the community organizer for Open Cluster Management, as well as an active participant in the open source project around the Kubernetes ecosystem.
Awesome. Mikela, you want to introduce yourself a bit as well?
Sure. Yep, my name is Mikela Jackson. I am a writer with Red Hat Advanced Cluster Management. And I'm also a participant in Open Cluster Management project and have been enjoying myself, at least just learning the ins and outs of open repositories and what that means to actually be a contributor. So yeah, thanks for having me.
Awesome. Thanks for joining, folks. I had tossed up, their GitHubs and socials are there if anyone's interested in reaching out. We'll get more into the project here in a little bit, some of the interesting links and where people can get involved. But first, as always, I have some top of mind topics. I think I've still shamelessly stolen from Ask an OpenShift admin. I'm still workshopping names. Hopefully we'll get Andrew his back soon. But that being said, the one interesting thing I have been kicking around with this week, and I know Mike probably has this near and dear to his heart as well. I have been once again in awe of and hacking around OpenShift GitOps, basically Argo CD. So I've been doing a ton of work in Argo, and recently it was brought to my attention, and this might be new, Mike, as well. I want to see what you think. They're potentially adding a Terraform integration to Argo CD. So it'll allow you to provision infrastructure and do other Terraform applies and runs and actions through Argo CD. So you can do declaratively through GitOps configuration of infrastructure. I don't know if you'd seen that at all. I can hunt down the link for that if you're interested.
Yes, I am interested. That sounds really exciting. Thank you for sharing, Gurney.
Yeah. Looks like it's an Argo CD Terraform control. Yeah, here we are. I'll drop a link in the chat for everyone. Really interesting project. It is just in a pull request, but I'm pretty excited to see that as someone who's used Terraform in the past. And I think we'll get a lot of good insights, Mikela, as well, from the open source docs standpoint. This is one of the best written PRs I've seen as well. So I've enjoyed that. I know I'm bad about it. So
No, never that.
Mike, Mikela, any cool, interesting, or fun open source developments you guys have seen in the past couple weeks is the usual what we shoot for.
Yeah, we've been actively participating in the multicluster SIG, which is a part of the Kubernetes SIG. We work on the Work API, which we can say sort of it's a project that that the Open Cluster Management also originated from. So that is something that we're trying to contribute to the community to set a standard API so we can deliver workload from a centralized location to multiple locations. So that's something that we've been discussing and we actively participate on in the Kubernetes SIG front.
Nice. Awesome. Do we have to mention only projects within Open Cluster Management, or are you asking about just any projects that we?
All of the above.
Okay. So a project that I've been aware of for a little bit of time now it comes from the Linux Foundation company, and specifically it's called Ag Recommendations. Well, excuse me, the entire project is called Ag Stack, but there's one project underneath it, and that's called Ag Recommendations. And basically, it's a framework designed to help enable people to create applications as well, but it's related to agricultural. And basically, they're looking for contributors to help take information from the cooperative extension guide, and that's a guide that farmers use or anybody that might be interested in like pest control management or water management, things of that nature. But basically, there's an effort to digitize this information. And so personally, I'm looking to figure out how open cluster management can be used, how that framework can be used to create applications, and then be able to just add data, pull data, whatever for Ag Stack or the Ag Recommendations console, whatever is to come. Is still like in its early stages, but that's something that I've looked into in terms of open repos.
Wow, I had never seen this. I had never seen the Ag Stack. I know a lot of open source work was happening in the agricultural space. If there's ever a tinker community that's going to solve their problems, they're on their own. Agriculture's got some really cool makers, and that's amazing. I dropped a link. I hope it's the correct link to the agstack.org.
Yeah, that is. That should take anybody to the original page, of course, and then they have their GitHub link attached to that too.
That's incredible.
Yeah.
Okay. So the side conversation is, in college, one of my projects that I worked on was studying honeybees and monitoring honeybees with little embedded systems on the side of a honeybee hive, and we did machine learning to count bees and identify. So it's really interesting to see a whole open source Linux Foundation project dedicated to biological monitoring and agricultural monitoring. That's amazing.
Yeah.
I know I'll bring it up next week. We got to bring it up to Joydeep because I know there's a lot of data science to be had there, and that is his favorite thing.
Sounds good.
Yeah. Thanks for bringing that up, folks.
Mm-hmm.
Well, without further ado, I think it's time for us. That's a good segue to dive straight into why open cluster management is relevant, especially when maybe you have a few embedded systems that might be monitoring rain and soil composition and growth, and something maybe on a tractor at a cell site. And now you have 5, 10, 15, 100,000 different compute devices that you really need to connect and coordinate. And I think that stems directly into the open cluster management world. So what is open cluster management? What's its foundation? Where do we find it?
So one, you can find it, of course, on GitHub. That's something pretty easy. But let me start off with the summary of what open cluster management is. Again, my name is Mikela. And so open cluster management is an open source project. You go to the next slide. It's an open source project from CNCF, which stands for Cloud Native Computing Foundation. And it's designed to simplify and unify the management of Kubernetes clusters. And so today, Mike is going to also go into the architecture of open cluster management, which includes the hub and managed cluster architectures. And you can, with this framework, you're able to specify the distribution, you could specify the distribution of Kubernetes manifests just from your hub cluster. So Mike, I'll toss it to you now to describe the architecture and for the demo.
Yep, thank you, Mikela. So I'm going to talk a little bit about the open cluster management architecture. I'm actually going to head over to our websites where we have most of the explanation in the stock format. So open cluster management comes out the need to control and manage a fleet of cluster. So with the premise of you want to manage a single cluster and then grow that into a fleet of cluster, then you're able to maybe deliver a workload. Then eventually you'll have application lifecycle, and then later on you can apply governance and configuration policy across the entire fleet. So it just keep going up the stack as we build on top of the of open cluster management. So in terms of the overall architecture, it's a hub and spoke or hub and manage model. So it's the same model that Kubernetes uses for the API pattern. We're very fortunate to have several key members from the Kubernetes project as open cluster management maintainers. So the open cluster management design, it's heavily influenced by the existing Kubernetes design. So the key is, if you're familiar with Kubernetes on a single cluster, some of the terms and some of the design philosophy that we use in open cluster management should sound similar and work similar as well. So going back to the hub and spoke model, we have a cluster that can be act as a hub by running some cluster management controllers on it. Then the spoke or managed clusters with agent running in them will join the hub cluster. And this is the key point I want to emphasize, is to make the connectivity is actually initiate from the spoke cluster to the hub cluster. This is done intentionally because based on the community and user feedback, we didn't want the hub having to go through the firewall and reach out to cluster in a push-like model. So open cluster management is more of a pool model where the clusters, where the spoke or managed clusters are looking in the hub for work or the manifest that needs to be deployed and bring them down and to the managed and spoke cluster side and applying them. So as well from a scalability point of view, it's much easier to have individually similar agent running on those remote clusters doing most of the heavy lifting instead of in a push model where the controllers on the hub is trying to push down to 1,000 and maybe 2,000 clusters. So again, our hub agent is a pool model, so the agent is pulling from the hub once they're connected. But that being said, there's obviously cases where you want to do push, and we actually have add-ons that enable the push model as well. So it really depends on your use case. You can have a default decentralized pool model. You can have a centralized push model. And that is one of the benefits about open cluster management. It's really modular and extendable. So we provide a foundation where you can build your multi-cluster solution on top, and you can pick and chooses the solution that you want. So
Okay.
Yep.
Yeah. I was gonna say that we have a good question that lines up right here. So you said that by default it uses a pool model. So rather than having your hub component push down content to 2,000 different clusters, you're gonna have all of those 1,000 or 2,000 managed clusters, however many really, pull from that pool data, pool work to do from that hub. And then there's a concept of add-ons where add-ons can utilize their own interaction framework that might be more of a push, and some add-ons use that push model. So there's an ability through open cluster management, it sounds like, to do both a pull and a push, but you need to understand the constraints and costs and benefits. That sound right?
Yep, exactly.
Awesome. I hope that answers. We had one question in chat, so that might answer your question already.
Yep. So are there any other questions before I show it in action with a demo?
I don't think so. I'm ready to see it, Mike. I'm excited.
Sweet. Okay. So I got 3 terminals here. On the left side here, I have a kind cluster that is I set up sort of to imitate a hub cluster, and then on the right side here, I have they all newly created another client cluster that represent the remote cluster 1, and another client cluster that represent the remote cluster 2. So what what I'm going to be using is the cluster admin CLI tool. So this cluster admin CLI tool, we base on our experience from the kube admin CLI tool. So some of the commands might be similar and does the similar things. In a kube admin's CLI tool, you bootstrap a Kubernetes cluster with the control plane, and then you join worker nodes to that control plane. And then in Open Cluster Management, the cluster admin command, you initiate the control multi-cluster hub control plane, and then you have the remote cluster joining to the hub through a command. So in the interest of time, I already ran the cluster admin init, which essentially lay down the controllers for the hub on the hub cluster side. And after that is done, it also creates the service tokens so that we can use the service token to do the initial join from the remote cluster to the hub cluster. And it'll also spit out the commands that you can use to join the to request a registration from the remote cluster to the to hub cluster. So I'm gonna run one of both of those commands. So I have a copy here. So this will deploy the agents on the remote cluster side, and then once everything's done, that will generate a registration request to the hub cluster, and then on the hub cluster, you will have to approve it, because with the service token, anyone can initiate the request, but that doesn't mean that automatically this remote cluster is joined. The hub cluster admin still have to approve it as well. So I'm going to do that on cluster 2 as well. So while we wait, we can talk a little bit about the security, and then I'll go into more depth later when we have more slide to show regarding the registration process. So in this case, the sort of the remote or the worker cluster admin, they can list and then read the managed clusters and create a managed cluster request on the hub cluster side, and also we create a CSR request. But those CSR cannot be impersonated due to the fact that CSR only contains the certificate, and the client authentication require both the key and the certificate, and the key is actually stored in the key is actually stored on the remote cluster side, and it is actually never transmitted over the network. And the worker clusters, or the remote clusters, cannot approve his own cluster registration by default, because we have RBAC set up so that to approve a cluster registration, is only done by the cluster admin on the hub. So when you generate a request, a joint registration request, you create the certificate signing request, and then you also create managed cluster as well. So these managed cluster appears on the hub, but you can see they're not joined and not available yet because the hub admin has not accepted the join request. So now I'm going to accept the one of the clusters, and then I'm going to accept the other cluster as well. So we can go back and check the CSR, and now they've been approved. And then for both clusters, so now that means we set up the authentication between the remote cluster to the hub cluster, and the certificate will renew itself by the controller on the remote cluster side. And also in terms of authorization, we can look on the managed cluster side. So now the managed cluster are joined as well. So after you set up this connectivity, one of the basic things that you can do is you want to deploy some workload from the hub to the remote cluster. So this is done in Open Cluster Management through a Manifest Work API. So Manifest Work API, after the registration is completed, each remote cluster have its own namespace, designated namespace on the hub cluster side. So if we look on the hub, we can see these two namespaces are created. So on the remote cluster 1, it only has access to the hub cluster cluster 1 namespace, and same for the cluster 2. Remote cluster 2 only have access to the hub cluster's namespace cluster 2 as well. So to deploy a workload, we use the Manifest Work API, and then you wrap your workload or manifest in this API, and then you put it in the namespace, which represent the remote cluster that you want, and then you apply it on the hub. So now we can see that on the hub side, we can see that the manifest work has been applied on the hub, and then we can check on the remote cluster. It's been deployed on the remote cluster, and if we've checked on cluster 2, obviously there's no deployment yet because we only deploy on the cluster 1 namespace, and the cluster 1 doesn't have permission to access the cluster 2 for security reasons. So we'll do the same for cluster 2, change the namespace here to cluster 2, and we will apply the same Manifest Work API. And then we should be able to see the pod running on the remote cluster as well. So that sort of gives the most basic foundation block of Open Cluster Management, the key of registering your remote cluster to a hub cluster, and then you can deploy some workload towards your remote cluster. So before I continue on, are there any questions?
Yeah, so functionally what you just showed us is an entity that has access to a cluster they want to manage and a cluster that they've created and configured as a hub using cluster ADM. They've created a request to start managing a cluster. They've used that request and certificate to create artifacts on the managed cluster. or the cluster they want to manage to initiate that handshake. And then they've approved that handshake on the hub side so that communication channel can be open. And once you've done that, their certificate is renewed automatically by the hub and managed cluster pair before it expires, so that that link isn't broken. And then you used manifest work defined in the hub to have the managed cluster pull that configuration, not push, but pull in that case. Okay, we have a couple questions. The first one is a note. Next time we go back to the slides, we need to bump the font size, or sorry, the Open Cluster Management webpage. The link should be in chat as well. But the other question is to make sure, by default, push isn't mandatory, just pull. Push is an optional add-on, something that you can enable and utilize separately, but pull is the default out of the box.
That is correct. So I'm gonna explain add-on in a bit, but we do have add-ons available that allows you to push Kubernetes API requests to the to managed cluster.
Okay. Can you bump the font size here just a little bit? Awesome.
So you need to set up a cluster proxy add-on and a managed service account add-on, and then you follow through the setup. Then at the end, you can actually use with the hub qconfig, you can actually proxy through to your remote cluster. So with that ability, then you can push whatever workload you want using this cluster proxy.
That is awesome. And it looks like, thanks to Patrick in chat, someone else was curious about giving this a try in a home lab. So the behind the scenes, pulling back the curtain, Mike told me ahead of time, all of this demo is actually running off of Kind clusters on his local machine. So Kind and Cluster ADM can actually get you basically what Mike's doing for the demo today is what he told me, right?
Exactly. So all three of my clusters were actually freshly created today, Kind clusters. So in our instructions, they have about setting up a local Kind environment to do the initial bootstrap and testing as well.
Awesome. This is pretty great. I'll be honest, I've definitely been to plenty of these community meetings, but I have never actually played around with the manifest work API, which that's pretty incredible. That's a great easy way to push different Kubernetes manifests direct between clusters. What's the overhead look like? I know we have a lot of scale sensitive folks in chat. What does the overhead look like for the footprint on a managed cluster?
So it should be pretty lightweight because our agents are quite small, and we're not using a polling system for watching. We're just watching from the remote cluster side and watching on the hub cluster side. So on manifest work, you can actually configure status sync. So say, for example, you look at a pod and then you see these certain statuses, and you want to sync those statuses back on the hub side because that's where you manage your entire fleet. So there's also an option in the manifest work where you can configure that. But we definitely don't recommend syncing the entire status. We recommend you there's a JSON path configuration that you can pick on manifest work, and then you can cherry pick the status you want, and that'll become quite lightweight as well. So yeah, we run testing before, and we were able to support 1,000, like 2,000 clusters, no problem. There's some configuration tweaking needed in terms of the heartbeats going from the remote cluster to the hub cluster. Maybe I think the default is a little bit too strong, but yep, we we're in terms of scalability, because we're using the pool model, we're definitely able to support a large fleet of clusters.
That's awesome. So basically what you're saying is the user gets a lot of dials to tune for how, basically, if you have 10 clusters or 20 clusters to monitor and to roll out 10 manifests to, maybe you can actually send back a lot more rich detail. But if you're running 1,000 manifests to 10 different clusters, maybe you just want the status item that says ready or not ready, ready, true, false. And that's what you care about. So you can specify that. That's a really cool amount of configuration. And this is definitely feels like a foundational tool that a lot of people can build on top of. I know, spoilers for the community, I think some folks are building on top of this. This is a foundation. But that's incredible. So you've mentioned add-ons a lot. I think this is probably where you're going next. But is there any way for folks to contribute and build and extend add-ons themselves and pick up pre-existing add-ons? I know also Mikela may have some comments in the docs side of things, because I know Mikela's been crafting a lot of these docs to make sure that you can actually understand how to build an add-on. So I'm always curious about that.
Yep, I'll go into the more technical details about registration as well as add-on later. But are there any other question of the demo before I pass it over to Mikela to talk about where you can contribute or where you can participate in the open cluster management community and possibly develop an add-on, for example? If not, I'll pass it to Mikela right now, and talk a little bit about the community side, how to get involved and how to engage with our open cluster management community.
Cool. Thanks, Mike, and great job on the demo. Do you mind selecting to present the presentation so it could come up a little bit larger?
Like that?
Yep.
Okay.
Yep, there we go. Thanks. Okay, so yeah, like I mentioned earlier in the video, make sure that you all start with going to GitHub first. That's where you'll see a lot of resources. You'll get a view of the README, and you can even contribute in that way. So that's something that's amazing about open source and learning how to become a contributor, because despite any knowledge that you don't have right now, or any knowledge that you do have, you can define the value that you have and go ahead and maybe just make a suggestion or anything like that. So one way that I do, like I mentioned before, I'm a technical writer for the product team. And so one way that I know that I can contribute is through documentation. And so if you see something wrong, a misspelling, or even maybe we're using the wrong API or something that's described, you could put in the issue, create an issue, describe what the problem is, and then that will eventually be solved. Or you can solve it on your own, and you can create a pull request and get it reviewed by one of the maintainers and things of that nature. So you can contribute. It's different projects within open cluster management. So you might see something like Mike was adding. You might, he was speaking about add-ons. You can contribute to the governance policy add-on project, or you could contribute to an API project. Whichever project, piques your interest, feel free to go in, dive in and see what issues are already created, what PRs are in progress right now. You can also join the Slack channel and see the conversations there. Join the community meetings, which often happen, I believe, at like 10:30 on Thursdays usually, but Mike correct me on that information if I'm wrong. And then you can also tune in on YouTube like you're doing now, or on Twitch, and just get involved with the community. That's how the community moves forward. It's through different contributions from outside or external contributors, and just to help build collaboration within the org and stuff. So, yep, back to you, Mike, on explaining add-ons.
Thank you, Mikela. Yeah, I just want to touch up on our community meetings. So because we have contributed from the West Coast, East Coast, Canada, Israel, Europe, India, China, etc. We have actually 2 community time slots. One is 10:30 Eastern Time, and the other one is 9:30 p.m. Eastern Time. The 10:30 a.m. Eastern Time is in the morning. So we rotate that on bi-weekly basis. So feel free to, it's a completely open community meeting. So feel free to join in, and then we can talk about whatever problems or whatever suggestion you have for the community. So thank you, Mikela, for that quick plug on our community side. So I want to go into a little bit deeper on the cluster registration and how it actually works. So the in the demo, I glossed over some of the details around who does what. And since the open cluster management is really about building a foundation block, and the very foundation, and then you build on top of that foundation, and the foundation piece is the most important, is the act of registering or joining a managed cluster to the hub cluster. So we get a lot of questions when a organization or a team comes to want to participate in the open cluster management. They want to know that it is secure. It is done and designed properly from the base up. So I'm gonna be using some of the slides that were provided by David Ease. David Ease is one of the key contributor of the Kubernetes project. On GitHub side, he probably was participating in the project since the very beginning of when it was brought over from when Google open sourced the Kubernetes project. So my explanation is probably not going to be on par as his, but I'm going to give it a try. So when we first started, we have 3 actors. We have the hub, the managed cluster, and the hub admin. And the bootstrap identity is what we started with, which was the service account. So service account that the hub admin share with the remote or the smoke cluster, and the managed cluster uses that bootstrap identity. Basically go like, hey, I want to create this custom resource managed cluster. I want to provide some information of what I am. So do you accept me here? And here's my current life cycle states. And there it contains other information like labels, and then cluster claims, which sort of describe what the managed cluster is, and then we can build more functionality on top, as well as the creation of the CSR. So in a certificate signing request, it is in the name shape like this. So it's in a format that the hub admin can recognize. So after it's created, you saw that we have a chance to approve. So after the approval, you actually we won't use the bootstrap identity anymore. It actually create a more persistent kube config on the managed cluster side, and then it can renew itself and then access the hub cluster again. And this is how the manifest work actually function. This is how we sort of keep the different cluster distinct from each other and what access rights they have. So once you accepted the managed cluster, the hub cluster, actually creates a namespace, as I mentioned in the demo. So because the way the manifest work, we want the managed cluster to reach out to the hub. So we need a way for the hub to distinctly manage cluster efficiently and only grant access to a subset of resource. So we want to avoid the situation where managed cluster one is able to get information from another cluster like managed cluster two, or even modify the status of managed cluster two, because you can, if you allow managed cluster one to modify managed cluster two status, you can sort of steal all the workload. You want to you say managed cluster two is really busy now, give me all the workload, and that way you can sort of steal contents that way. So in open cluster management, we're using Kubernetes RBAC on a namespace level, so it's efficiently to evaluate. So because we know precisely which user we need to grant access, then we can have them match inside the namespace, and that really gives us the ability to segregate the workload delivery. So when we look at it after registration, we can see how the managed work get its detail associated with its cluster, and with that identity, it contacts the hub and retrieve the custom resource called the managed source work, which we show. And inside the manifest work, it contains the workload, and then each controllers we have to deploy the resource on the remote cluster side. So it's also important to know that the manifest work can create almost anything from like namespace to custom resource or add-on, whatever it needs. And because there are RBAC that's associated with it, so if there's an evil managed cluster trying to access another cluster, it'll get its access rejected.
So
yep, go ahead.
Not only do we have a secure connection that has to have a hub and a managed cluster agree to become connected, but you're also saying that the mechanisms baked into that foundational handshake protect from cross pollution and kind of cross access. So you can give role-based access control to, you can RBAC access to a single managed cluster, and know that if someone can access rolling out manifest to that managed cluster that might be owned by app team A, app team B can't access the other managed cluster unless you give them access, and those managed clusters can't cross access either. That's really interesting. That's really good.
Yeah, and it also helps with cleanup as well. We want to segregate everything on its own isolated namespace, so that it's easy to sort of clean up a managed cluster if the managed cluster wants to be deregistered from the hub. Are there any questions before I go into more details about the add-on? Okay, I'm gonna go into what an add-on is, because what if I want to be like work? So what naturally comes out of this is I want to have a controller that runs on the managed cluster that communicates back to the hub, and that uniquely identify and perform whatever operation you want. So we call those add-ons. So there's a couple criteria to determine if you're add-on. For example, if you need to read data from the hub, so you can use it to figure out what information to feed or act on. Also, do you need a different configuration for different managed clusters? So that will be a good use case for an add-on as well. If you need the same configuration across all different managed cluster, you can consider using other mechanism. Like you can install GitOps on the hub cluster, and then you just sort of distribute the same the same configuration across multiple cluster. So to support this to support this add-on, we define a couple of concepts. So we have the add-on manager that runs on the hub that distribute the resources, which is the add-on to the individual resources, individual clusters. And then we also have the add-on agent that runs on the spoke cluster that work almost similar to the work. It reads from the cluster and acts on the spoke, and it pushes a small amount of data back. So one of the thing that was asked is regarding scalability that was brought up. So what if I want to push a lot of data back, or I want to use something that is not a normal REST resource back? So then we get into the access pattern that we sort of don't encourage for add-on. We don't encourage to a large amount of data sending back to the API server through the add-on, which essentially make the add-on sort of act like a proxy. And if you want that, one way to do that, as David suggested, is you create an endpoint that on the hub side, and then you can expose that endpoint to handles that better. And Open Cluster Management actually provides a library that lets you perform the CSR dance, which is the creating a CSR request and then accepting it that we talked about and demo about earlier. So that's another use case for Open Cluster Cluster Management. You can use that library to build your as David called it, the awesome data recorder, and having the awesome data recorder sending a big amount of data and even non-REST data back to the hub. So this is basically it in terms of my presentation. In terms of our presentation, we talk about how to join a cluster, what happens during the joining process, what happens afterwards, how does the information flow look like, how does the permission look like, how to keep the data segregated, and how do I create and how do add-on work. So there are still a lot of other APIs on Open Cluster Management. For example, we haven't touched the placement API, which is a really powerful API where you can determine which clusters have allocated resources, and then you can use the placement API to determine, hey, that cluster 1 actually have more resources than cluster 2, and I'm going to push the workload towards the cluster 1. And there's add-ons. We have native add-ons like application life cycles. We have governance policy add-ons. We also have the cluster proxy add-ons, etc. So that really allows you to build functionality on top of Open Cluster Management as well. And so yeah, please give it a try, and we welcome all contribution. We're very active on Slack. We're very active on the community meetings and the mailing list. Please feel free to give it a try, and we look forward to your feedback.
Yeah, that's awesome, Mike. So where would someone? So I'm looking at this. This is amazing. I see that there's add-ons for policy. I really like this manifest work thing. I see there's a proxy and a managed service account that look really interesting. Where would someone get started on figuring out if they should build and building their own add-on? So say they wanted to build another add-on, they want to leverage this, they have some specific use case and they want to extend what's out there. Where does someone get started? Is it this page with the what is an add-on and some of the details, and take a look at some of what's already out there?
Exactly. So head over to the Open Cluster Management, and then you can click documentation, and then we have all the topics that we talk about. We also have specifically for add-ons, we have the add-on page, and then you can visit the add-on framework GitHub, and there's more examples on how to build or what is a add-on as well. And we're actually creating from your feedback, from community feedback. We're actually trying to enhance our add-on development guide. So G-Way, shout out to G-Way in here for creating this add-on doc, add-on developer doc to further enhance the creating an add-on experience. And you can provide anyone can provide feedback to the doc and see if that helps with the experience in terms of developing an add-on.
That is awesome. Someone already linked it in chat. Feel free to ask any questions, folks. I surely have a few in the interim. My favorite question to ask anyone in an open source community, especially anyone who's been as involved and involved for as long as I know Mike has. What is your favorite part of open cluster management? Is there a part that you helped write, that you helped architect, that there was a heated discussion about, that is your absolute favorite? Mike, Mikela, I don't know if you have any favorites. You don't have to pick your favorite child, but what have you enjoyed the most?
Mikela, you want to go first?
Sure, I can go ahead. So I would say my favorite part is when I do have the opportunity to do so, is to review the documentation from the open source, or at least open cluster management repo. Like I said, when I have the time to do it, usually I'm already doing just regular product docs, but when that opportunity presents itself, it's definitely awesome to see like just the collaboration come together and be presented as this one website, or at least just this brand effort that we all are on.
Awesome.
And my favorite moment is when we get community feedback saying, hey, we're using a certain project, we're using a certain tools, but they are no longer scaling for our as we increase the amount of clusters, we no longer scaled out. And that's when I get involved in presenting open cluster management, saying, hey, here's a really modular, you can plug and play and choose the pieces you want solution. So let's see if this open cluster management can solve your scalability problem, your multi-cluster management, multi-cloud management problem. And I really get a joy out of that, being able to provide a solution for the community where they went into a certain roadblock in this multi-cloud, multi-cluster space.
That is awesome. Any other highlights from the community? Anything else that we might have missed? If not, we can wrap things up if there aren't any more questions, and we're always here for questions afterward. I'll drop here's the show contact. I'll also drop the email in chat. But yeah, any shout outs, Mike or Mikela, to the community? I know we have a rather large participating community on and off. So any shout outs?
Yep, shout out to all the participants on Open Cluster Management, whether you're from Canada, US, China, India, Israel. Everyone is welcome to join. And shout out to the organizations that have been really help building Open Cluster Management, Red Hat, Ant, Tencent, Microsoft, Expedia, Alibaba Cloud, and other smaller companies as well that really help us develop and foster this community, as well as the some of the key contributors from the Kubernetes space that really guide us in terms of the design. David Eads, Min Kim, Paul Mori, if I miss anyone, Q-Chang, if I miss anyone, I don't mean no disrespect. It's just the names that come out of my head. So shout out to them.
And I would echo Mike's shout out to everybody that you listed, and shout out to the future contributors. Just go ahead and give it a go. And shout out, of course, to the documentation team from Red Hat Advanced Cluster Management. I got to shout the team out, but shout out to everybody that has contributed and who continue to do so. So thank you. And thanks, Gurney. Thanks for organizing this and hosting it consistently and with grace. Bro, you do a great job.
Yes, thank you, Gurney.
Yeah, thanks for coming on today, folks. So I dropped a link in chat for the Open Cluster Management IO project. Go take a look, maybe write an add-on if you have the concerns. Come to some of the community meetings. I know I make it from time to time, normally the North America ones. I'm a bit of an early to bed person, so I tend to miss the other ones. But thanks, everyone, for coming and joining today. And we'll see everyone in 2 weeks. I don't have the topic finalized for that one yet. It's one of two, so I'm not going to tease it. But as always, you can find announcements on Reddit and Twitter to find out what we'll be talking about in a week's time. So we'll see everyone back here in 2 weeks. And maybe Mike and Mikela, they'll come back another day, or we'll do a cross stream with an Open Cluster Management community meeting. Who knows what is to come. So thanks, folks. I'll roll the intro as the outro as always. And we'll see everyone in 2 weeks.
See ya.